In problem number 1, we are told that the cost function for a certain product is linear. The fixed costs are $4,200. The marginal cost is $25 per unit. The demand equation for this product is Q equals 180 minus P, where Q is the number of units demanded by the customers when the price is P dollars per unit of the product. We're told also that the company manufacturing the product always prices the product at the highest price at which all units manufactured will be sold. And we need to determine the smallest number of units of the product that must be manufactured and sold to break even. Let's begin with the cost function. So since we're told that it is a linear function, we can write that the cost of manufacturing X units of the product, C of X, equals to mx plus b. This is an equation for a linear function, where b is the fixed costs and m is the marginal cost. Since we're told what those are, we can write down the equation completely in a completely determined form. M is 25, so we're going to have 25 times x plus 4,200 for the fixed costs. Okay, so that's the cost function. Now, maybe I should have used q instead of x. Let me do that. Q is the number of units of the product that are being manufactured. Now, let's also look now at the revenue, R of Q, the revenue that the company will receive if it sells Q units of the product. Of course, the revenue equals price per unit times the number of units sold. So in other words, P times Q. And now let's think about the sentence in the problem which talks about how the company prices the product. The company manufacturing the product always prices, I'm looking at this sentence right here, the product at the highest price at which all units manufactured will be sold. We have the demand equation, Q equals to 180 minus P. So let's say the company manufactured a certain number of units of the product, Q. We can determine from the demand equation the corresponding price P, and that is actually the maximum price, the highest price at which all those Q units will be sold, right? Because if we take that value for P that comes out of this equation, then the corresponding value of Q is the one that we started with, and that's the quantity that will be demanded. And since it's equal to the number of units manufactured, all those units will be sold. Now, if the price is higher than that, then of course the Q value will be lower than the one that than the number of units manufactured, and not every unit will be sold. On the other hand, if the price is lower, of course the demand will be higher. All of the manufactured units will be sold, but it will not be the highest price at which all units manufactured will be sold. In other words, the sentence that talks about the price being the highest price at which all units manufactured will be sold simply means, in concrete terms, that the value of P can be determined from the demand equation given the value of Q. Okay, so the demand equation is Q equals 180 minus P, and we will solve this equation for P. P equals 180 minus Q. And we will now plug in 180 minus Q into the revenue function instead of the price P. The result is 180 minus Q times Q. Now, for any value of Q, we can calculate the cost, to manufacture Q units, and we also can calculate the revenue obtained from selling Q units. Let's now recall what the break-even point is. The break-even point is the point at which the manufacturer recovers completely his or his costs, but does not make in the profits. So in other words, at the break-even point, the cost equals the revenue. And so to find the break-even point, what we need to do is we need to set the cost function equal to the revenue function. And then we will be able to solve for Q. C of Q equals R of Q. In other words, 25Q plus 4,200 equals, for the revenue function, let's multiply out 180Q minus Q squared. Okay, and now let's move all terms to the left-hand side. This is a quadratic equation, so let's write that equation in the standard form. Q squared, 25Q minus 180Q, that's going to be minus 155Q plus 4,200 equals 0. Okay, and now we need to solve for Q. Actually, let us look at what the problem is asking. The problem is asking us to find the smallest number of units of the product that must be manufactured and sold to break even. So we're looking for that value of Q. And so let's go ahead and solve this equation for Q. Considering the values of B and C are fairly large, I would recommend using the quadratic formula. So Q will equal minus B, 155. Plus or minus square root of B squared, so negative 155 squared. Of course, it wouldn't really matter whether you square negative 155 or positive 155. And then minus 4AC. A is 1, so 4 times 1 times C, 4,200. And then all of that is divided by 2A, but since A is 1, it's just 2. Okay, and let's now think about whether we need to take a plus or minus in this formula. Since the problem, so the equation will have two solutions, right? If the number under the square root is positive. And the one that we obtained by taking the plus sign in this formula is going to be the larger one. But the problem is asking for the smaller one. And so if we want to get the smaller one, we are going to go with the minus sign. Let's quickly calculate, using a calculator, the square root that we have in this problem. So it's going to be the square root of 155 squared minus 4 times 4,200, and that comes out to equal to 125. And so our solutions for Q will be 155 plus or minus 125 divided by 2. And as I mentioned earlier, we want the smaller solution. So let's take the minus sign in this formula. Q equals 155 minus 125 divided by 2. 30 divided by 2, that's 15. And so the company will have to manufacture at least 15 units to break even.